You are at the Good Decisions webinar for AI Governance Insights. And this month, we have Jim Olsen, the CTO here at ModelOp, and he's going to be talking about small language models, agentic AI, and the future of model governance. And without any further ado, I'll pass it over to Jim, and he is going to dive right in.
Okay, everyone, welcome to today's session. As I said, really, everyone's hearing about agentic AI. It's obviously a hot topic out there, and there's the reality of what does that actually mean for governance, and also what's changing within agentic AI that's making it a more interesting solution and coming more and more to the forefront. So first, we're going to talk about a lot of the agentic AI solutions you've seen today, which are built on LLMs, and understand what's being done there, some of the risks and challenges with using that approach. But recently we've seen an explosion in SLMs, or small language models, and so we're going to talk a little bit about them and why they are going to help change the landscape in agentic AI. They really are kind of a game changer. It's going to make it more attainable for a company and more realistic for an enterprise to actually deploy and use agentic AI. So we're going to get into that a bit. And then we're going to look at an example, very simple agentic AI architecture to understand kind of some of the components and players within that space, and then move on to, okay, now that we understand the models, what's going into them, how this space is changing, how do you actually represent an agentic AI solution in a model inventory for governance in a solution such as ModelOp Center, as well as what that means to actually track those solutions as well. So we're going to go through all that today in a bit of detail. So to get started, agentic AI, it's a term a lot of people are throwing around. Sometimes it's just buzz, sometimes it's reality, sometimes it's something in between. A lot of people don't have a clear understanding yet of exactly what agentic AI can mean to them. So agentic AI at its core, what it is it's the idea of a system that's going to actually act in an autonomous manner, to use varying agents to actually perform the tasks, make the decisions, achieve the specific goals, use tools, etc. on that. In general, it's got that goal-oriented behavior. The idea is it's hands-off. A human doesn't have to get involved to make those decisions, although many people as safety guard do want a human review process on that. They also need to basically have an ability to analyze and plan and take action as situations change, or also as they acquire real-time data that dictates the different behavior. So it's both that dynamically changing conditions, but also situational awareness of what's going on and what it should do, and etc., and do that in a meaningful way that achieves the desired goal or outcome. So the thought is that they are basically have human-like reasoning to be able to do that. Now, we all know there's a big differentiator between true human reasoning, but we understand what a reasoning model is and how it can iterate over the process to have those decision-making capabilities to solve complex problems or novel problems in a way by pulling the tools and information and agents and et cetera together. In reality, agentic AI, to really work well, is going to need to use expert models inside of their agents to accomplish those tasks. And when I refer to expert models, what I mean is ones that have knowledge about specific tools, products, interfaces, data structures, something like that, in order to achieve the goal. And a simple example would be like, at least has to know how to talk to a REST service, pull out information, and pick the pieces it needs to actually accomplish this task. That's kind of an expert model on that kind of thing. So when we get into that, we can start to talk about the different models and what they play within an agentic AI solution. So, where we see a lot of the solutions today is kind of, for lack of a better term, what I call the brute force approach, which is using a large language model as the expert model. The models, have to basically be, as we mentioned, an expert in the domain they're at, but that means that the LLM is going to need to contain all of the knowledge for all of the tasks it's going to perform. You're not going to deploy 20 agents with 20 LLMs. I mean, you technically could, but that would be very, very cost prohibitive. They require a lot of resources, et cetera, and that. So you're not going to have a ton of these out there. So your best approach will be to put all of your knowledge in one LLM, or to, a couple different LLMs that then can service multiple agents and carry that. And then basically, as I said, these typically are not even self-hosted. Obviously, they can be if you have enough hardware, et cetera, but it is somewhat cost prohibitive. So you basically often also face the challenge of not being able to self-host these models as well, if you can on that. And that means exporting potentially critical data outside of your enterprise walls, which we won't want to do. And when we look at the foundational models, often they're going to be up for a lot of the tasks you want. I mean, they know how to process JSON. They know how to talk a REST service. They know basic information about what a flight is, for example, or things like that. So out of the box, they may be up to the task, but if you have a specialized area or a very specific task you want to do, they may not have the knowledge at all. I mean, they don't know certain math problems. They don't know certain items. If it wasn't put into the training data and it's novel enough, they may not be able to perform the task at all, or worse yet, as we've seen, especially with some of these reasoning models, they may just make something up. And of course, that's not going to be good when we're talking about things acting in an autonomous nature. So what can you do with LLMs if you're heading down that approach for basically creating a specialized model that it all encompassing for your business? Well, then you would need to basically do reinforcement learning within that to basically create the expert model that has this. So basically, we would start with the foundational model and then do reinforcement learning that. And to do that, you use a reward model that basically rewards correct answers within specific domains and basically reinforces that learning through a reward. And then a loss model needs to be developed that actually kind of counters that and determines how far off the answer was to how much reward it should get. So you have these reward and loss models that work together to basically enrich the existing foundational model with the specialized information. And this is not cheap. It requires a lot of training, a lot of additional resources, a lot of GPUs, and then you've got to then take that huge foundational model and actually push it out there, the augmented foundational model, I should say, out there onto your hardware likely at cost, and have enough capacity to service all of your running agents that are out there, which obviously could be a very significant workload, especially as we get more and more agents working together to create a solution, which would create a slowdown on that. So, a lot of people are in the agentic AI space are just starting with the foundational models, not adding that, but that often means you're sending all of your data out of your enterprise solution into this vendor space. And is that safe? And is that what you want to do? We've already talked about the self-hosting challenges. I don't know if you checked the prices of GPUs lately, but it isn't cheap. Very expensive to get together, deploy, even if you can get the GPUs you want, because there is some shortages there as well. And it's going to take you a bit of time to train it. So what's been really interesting recently, and we've seen these pop up more and more, are the idea of small language models. Basically, small language models are designed with fewer parameters and lighter computational requirements. They can even be run on a simple GPU, like a desktop GPU or that kind of things. They're great for edge cases or areas where you don't need as much particular knowledge in an area. For instance, like I've been playing personally with DeepSeek R1 distilled Quen. And it's actually pretty impressive. And I can run that a quantized 4-bit version on like their 7 billion parameter one, and it runs in 4 gigs of GPU space. So I have a small, just standard off-the-shelf GPU. I can run that locally with acceptable performance. I've even pushed it down to the 1.5 billion token, and I was getting very reasonable responses, asking questions about model governance, and respond within, probably about 5 seconds or so on a very underpowered GPU. So that, is pretty impressive, and starts to talk about, hey, now we can deploy these things locally on that kind of things, and then we can get them more trained on a specific task, et cetera, on that, so that they can run off a very reasonable and affordable hardware, and then you avoid the whole problem of shipping these things off-site to deal with them on that kind of things. So what really changed there? I mean, distillation has been around for a little while. So it's been used in traditional mathematical techniques. As a matter of fact, I think one of the most downloaded models that's a distilled model is like a distilled version of Espert that works really great, works better than the original, and is faster requires less computations on that kind of things. What's interesting with those is we use one of the foundational models to then teach a smaller model just the areas we want to do. So hence we distill the information from the teacher being the foundation model to the student being the small language model, and enrich that small model with that information by using simple question answers and teaching it how to respond to that. So thus we can condense the information from that larger model rather than bringing the entire everything from the entire sun into that smaller model. We bring the areas of expertise that we want into this distilled model. Now the challenge there is, once again, we get back to the larger model still needs to already contain that knowledge that you want to distill, because you can't distill from nothing. But it's a great technique that is a much lower cost. I mean, I think some of these distillation models off of DeepSeek R1 were costing like only thousands of dollars to train, versus massive quantities of GPU time to train the original foundation models. The challenge we do see is sometimes you may get an oversimplification of the task, because yes, compression is lossy, so we lose some information, we lose that. But it does open up the world to be able to create these expert models in a realistic, cost-effective way. So now we actually can run these SLMs. We can create these specialized agents. So now we can start to take advantage of agentic AI in a realistic enterprise space, because basically we can now have these and deploy these and run these and not ship our PII data out to a vendor and trust that it's not going to be used for other services. So what does a typical agentic AI architecture look like? Well, this is kind of a very, very, very simple example. We don't want to go into a large one for the purposes of this example, but the idea is, like, for instance, what we're going to look at today is an automated customer support, where it brings together account information about the customer, tickets that may have existed, been opened in the past, closed, etc., about the customer's issues, both now and in the past, as well as information that's specialized about the product in question on there. So we're going to want agents that can actually pass that information back and forth between each other and actually answer the question with knowledge not just about the product, but also what they've done, what they've tried in the past, information about who they are, where they are, et cetera, on that. So to do that, you have a series of agents, and in this case, we're going to have 3 agents: an account management agent that knows how to talk to our specific accounting system and pull out information about the clients that are pertinent to customer requests. We're going to have an ITSM agent, which basically knows how to talk to our ticketing service and pull out information from the ticketing service relative, again, to that person, whether it's open, closed, issues we've resolved in the past, et cetera, and be able to bring that information into play. And then a specialized distilled model that's been taught everything about our product and what it can do and how it can do it. And one way you can do this using a foundational model is to have a foundational model augmented with information, a RAG architecture that is then used as the teacher to teach your distilled model. So now you've augmented without having to use reinforcement learning on an LLM, yet still adding in your specialized knowledge. So we have those 3 agents, and then there's a supervisor. As I said, and this following kind of the lane graph approach to it on that. That will actually kind of be the orchestrator and pull together the different information from the individual agents to actually pull together the response to the customer for each question or whatever they're asking as we go through this conversation. And then we're going to finally have a Rails output validation, because we still want that final line of protection against hallucinations, PII disclosure, profanity, toxicity, all of these kinds of things. Of course, as a professional organization, we would not want to be responded to the client. So we're just going to have that in place. So you're going to see where all of these components make up one solution. That's starting to be a heck of a lot of models in there that we actually need to keep track of as to what's going on. So how do you do this in the real world? And that's a challenge as these agents explode, because this is a simple example. You can imagine a real example where I've got 20, 30 agents in there. How do I know what's going on in my system? How do I know what was deployed when and how they were approved? Well, that's where we need to track the agentic AI, because we do have all these different expert models that are out there. And these expert models may be shared between solutions. If I have the ticketing one, that may be used in 5, 6, 7, 8 different solutions. There's no reason that we wouldn't reuse those expert models on that kind of thing. So we need to track the performance of these experts generically. So not tied to the use case, but actually just how are they performing overall? Are they outputting PII? Are they, et cetera? These kinds of things. But then we also want to track the overall performance of the solution that is using that expert to make sure, okay, well, as it's applicable to this use case, how specifically is it performing? Because they can be very different. They can share commonalities, et cetera. One particular use case could really expose a flaw in it where it degrades the system, or just how it works with the other agents itself could cause these kinds of degradations. And you need to be able to track that. So you need to provide basically that governance of all these different agents of tracking what's going on, what's been approved, how are they versioned, which ones were there, what distillation techniques were used to actually create these, and never mind if we're using these models in an overall solution, are there any state or regional regulations that you are compliant to, like in the healthcare industry, where you must disclose to the state that these are helping make a decision about a patient healthcare issue, for example. There's several states that require you have certain disclosures to remain compliant. So you really need a solution that really pulls that together. And that's where, as
Hey, Jim, just
yeah.
on that note in healthcare, and sorry to interrupt you, we got a question actually from a healthcare provider on kind of on that topic. So as you've set up these examples of AI agents and you're going through the architecture here, is the expectation is it that these agents are expected to behave and perform in the capacity of a trained SME? Are they to replace an SME, or are they meant to kind of work with the SME? I'm just kind of curious what that level of expectation of functionality is for that agent.
Well, that gets down to whether we talk about truly supervised agent solutions or unsupervised agent solutions. The true quote unquote holy grail of an agentic AI solution is that they are autonomous and act without supervision and run and solve the problem correctly. Now, I don't think that's realistic at this point in time for a lot of solutions, especially in something like healthcare. And in that case, you would basically expect that they do pull a whole bunch of information, make recommendations. You would have a person in between there that would then get fed all this information, all of these the things, kind of like using cursor to code with quote unquote vibe coding or whatever. You don't just take the answer as it is. It comes back, it's suggested to you, you review it, you make her, you may go with it as is, or you may go, well, no, it's not taking this into account, and then respond directly to the customer. So absolutely, I mean, if I was deploying a solution like this in a healthcare situation, I would have an actual subject manager, SME, that's sitting there and reviews these responses, but perhaps these agents are helping them be a 10xer basically by providing them all that background information.
Awesome. Thank you. That's perfect.
Yeah, no problem. So when we get to how we represent these in there, as I mentioned, we want the actual use case of how these agents are being used, because we will share the individuals in there. So it will describe the overall solution, like automated customer support on that kind of thing. So we'll track information about how we collect enough information about the use case, have we collected data samples, regulation of appliances, et cetera, on that kind of things. And then the use case is referenced to the actual implementation. So you can tie one or more implementations to it. So you can see, for example, here where we have implementation made up a series of agents and lane graph code and Rails. So to do that, when we describe the implementation itself, we use something called a model ensemble. I call it a model of models, where we do actually have to track one or more models. Now, this is not unique to agents. Agentic AI just leverages this like many other solutions. It's not unusual. You have transformation models, embedding models, a whole series of different models that play together to create an overall implementation. But, by tying it to a use case, we can say there's a use case that refers to an ensemble, that the ensemble actually pulls together all the parts of the implementations. And, any one of those sub-implementations can obviously refer to basically an agent that's used across multiple implementations and multiple ensembles. So we have that. So agents are one part of that solution, but like our Rails files we mentioned are another thing you're going to want to track, and you're going to want to track the performance of those. Have you tested those? Are we sure they're working and stopping toxic behavior or stopping profanity or whatever they're configured to do? But then we also want to basically track that overall supervisor, the LangGraph Python code that's specific to the use case task. That comes in there and pulls together those agents. So by having an ensemble where we break down these pieces, we can both track the individual shared components, but also look at the pieces that are unique to the use case itself. And then that way, it enables us to track the overall solution to see how it's doing within the thing. So we can be checking things like gibberish, user feedback, like if they're giving thumbs up, thumbs down, sentiment, toxicity, PII, all of these kinds of things as specific to the use case. But we can also be doing that looking at the individual agents themselves, where we've basically taken the DeepSeek R1 Quen and distilled it specifically to do account management or ticket management, et cetera. And we can track how the outputs of that are doing across all solutions. So we can have that visibility into there as well. So you do want to have a product that provides that kind of ability to see both what's going on with the agent as used across everyone, as well as specific to that use case. And that's a very important thing to be able to do on there.
Jim,
and then
terminology check. When you for the term model lineage, does that refer to just the kind of the process and concept of tracking agents, or is there?
Well, it talks about the full lineage of understanding what went into the model, the data, how many snapshots, which versions, what chunks of code, if code is applicable to that particular one. It's everything about the details of the solution itself. So understanding what went into there and that. So. But as we talk about, basically, now we're going to have all of these different models. We have 20 different distilled models going into our solutions and having agents on there. We absolutely need to also then automate as much as we can. One of those big items to automate is risk determinations. Our product actually has that ability to basically ask specific questions, and based on answers or the data it uses or any other attributes about the model, we can actually detect and say that there's likely a specific risk, automatically create these risks, and then track that. For instance, it's an EU, it's going to be used in the EU. Did you provide the EU evidence that the EU requires to actually do that? Or, has it been reviewed for complexity? And then actually automatically resolve those risks as the conditions are met. So they upload the file, the risk goes away. It's marked, well, it doesn't go away. It's marked that it's been completed. We track that we did it. We have it, again, talking about lineage, we have all that information there, but they don't have to go to like 10 places to resolve this or manually do something. They just meet the conditions automatically detected is met, and then the risk is marked as closed, or an approval in Jira is met, or, or within our system or any of those, but it needs to scale. That's the point, as we get into agentic AI solutions. So automation is key to having success using multiple agentic AI solutions on there. So that's where we kind of get to is, are you ready for this? Agentic AI is going, if you're going to bring it into the system, it's going to create that explosion of business critical models within your enterprise. They're going to dynamically interact in predictable manners. Which solutions are using which agents. Somebody may pick one up and start using it. You need to be aware that they're using it for that, because maybe they're not allowed to use it for that specific use case. And can you identify that and identify that risks? You must understand how the solution is performing, but also how your individual agents are performing across those solutions on that kind of things. And you must understand, have you done enough of an analysis of these agents and what they're doing to actually understand that, risk management has been performed, it's been tracked, we're complying with any regulatory things, but also we understand the risks of the business and what's there. That's where ModelOp Center is unique, that we're well positioned for handling these agentic AI. We put thought into that from day one. We've been doing this with regular models for a long time, but we basically designed it from the ground up to be a pure model governance solution. It's not a data science workbench transformed into that. Instead, it's agnostic to the data science itself, and instead it captures all that information, pulls it in, and it will handle all kinds of models, anything from an Excel spreadsheet.
All right. Well, I apologize for that technical difficulty right there. But Jim was wrapping things up and talking about just how ModelOp is that treats regardless of what type of AI it is, it abstracts the models from the data science tools so that everything kind of be treated and compared as apples and apples. And if you want to talk more about maybe how your organization is using agentic AI, or maybe you're just curious about it and how to properly scale it and govern it, we'd love to hear from you. So please reach out to us. We will send out this presentation. We will also send out the recording via email, and we will post it to our website, so you have access to all of the materials. We always make that available for the webinar, and we appreciate you joining us this month. We will announce our next. I'm just seeing Skip McCormick's comment. Was that really Jim, or was it an AI agentic model? Skip will never know. I guess it's just a black box experiment. So yeah, we hope to see everybody next month, and we appreciate you coming out this month. Have a great rest of the week. Talk soon, everybody. Thanks so much.